Towards excellence in SPM chemistry. In this slot, we will discuss a few questions from Chapter 2, Matter and the Atomic Structure, Chapter 3, the mole concept, chemical formula and equation, Chapter 4, the periodic table of elements, and Chapter 5, chemical bond. In each chapter, we will make a quick review and then discuss a few questions relating to the topics. Without further ado, let's begin with the first chapter. Chapter 2, Matter and the Atomic Structure. In this chapter, we will review the types of particles, the changes in the state of matter, and a graph of temperature against time for heating and cooling processes. Matter is something that has mass and occupies space. Matter can exist in the form of elements or compounds. Therefore, matter can be made up of three types of particles: atom, molecule, or ion. Atom is the smallest particle of an element that can participate in a chemical reaction. Examples are aluminium and helium. Molecule is a group of two or more atoms which are chemically bonded together. Examples are sulfur S8 and carbon dioxide CO2. Ion is a positively charged or negatively charged particles. Example, sodium chloride and ACl consist of sodium ion and A positive and chloride ion Cl negative. Heating and cooling change the physical state of matter. This diagram shows the conversion between three physical states of matter, which are solid, liquid, and gas. During heating, heat energy is absorbed. Kinetic energy of particles increases. The attraction force between particles becomes weaker. Solid changes to liquid, and melting occurs. Liquid changes to gas, boiling or evaporation occurs. Solid may also change directly to gas in a process called sublimation. Conversely, during cooling, heat energy is released. Kinetic energy of particles decreases. The attraction force between particles becomes stronger. Gas changes to liquid, and condensation occurs. Liquid changes to solid, and freezing occurs. Gas may change directly to solid in a process called deposition. This is a graph of temperature against time for heating naphthalene from solid to liquid. From A to B, temperature increases. Naphthalene exists in a solid state. When heated, the particles absorb heat energy. Kinetic energy of particles increases. Particles vibrate faster. From B to C, melting occurs. There is no change in temperature. Naphthalene exists in solid and liquid states. Heat energy absorbed by the particles is used to overcome the attraction force between the particles until solid changes to liquid. Melting is the temperature at which solid changes to liquid, which is the temperature at B and C. From C to D, temperature increases. Naphthalene exists in liquid state. When heated, the particles absorb heat. Kinetic energy of particles increases. Particles move faster. This is a graph of temperature against time for cooling naphthalene liquid to solid. From E to F, temperature decreases. Naphthalene exists in liquid state. When cool, the particles release heat and move slower. Particles lose kinetic energy. From F to G, freezing occurs. There is no change in temperature from F to G. naphthalene exists in liquid and solid states. Heat energy lost to the surrounding is balanced by heat energy released when particles attract each other to form solid. Freezing point is the temperature at which liquid changes to solid, which is the temperature at F and G. From G to H, temperature decreases. Naphthalene exists in solid state. When cool, the particles release heat and vibrate faster. Kinetic energy of particles decreases. Here is a question relating to the change in the physical states of matter. Diagram shows the graph of temperature against time to determine the freezing point of acetamide. A. State the type of particles in acetamide. The question asks for the type of particles. There are three types of particles: atoms, molecules, and ions. As acetamide is a compound that is not made up of ions, therefore it is a compound that consists of molecules. B. What is the freezing point of acetamide? Freezing point is the temperature at which liquid changes to solid. Liquid changes to solid from F to G. Temperature at F and G is 83 degrees Celsius. Therefore, the freezing point is 83 degrees Celsius. Remember to write the unit degree Celsius. C. What is the physical state of acetamide from T2 to T3 minute? As discussed in the previous question, from T1 to T2 minute, acetamide liquid freezes to solid at 83 degrees Celsius. At T2, freezing process has completed. Therefore, from T2 to T3, acetamide exists as solid. The answer, solid. D. Why is there no change in temperature from T1 to T2 minute? From T1 to T2, freezing occurs where liquid becomes solid. There is no change in temperature because heat energy lost to the surrounding is balanced by heat energy released when particles attract each other. E. If liquid acetamide is cooled too quickly without stirring during the cooling process, sketch the expected curve in the answer space. To draw the curve, start with the x and y axis. Make sure the axes are labeled correctly with units. Y-axis is labeled with temperature in degrees Celsius. X-axis is labeled with time in minute. As it is a cooling curve, the curve will be quite similar to the one that was given in the question. To obtain the correct curve, we must know what will happen if liquid acetamide is cooled too quickly without stirring. When this happens, supercooling occurs. Temperature will drop lower than the freezing point and increase back to its freezing point. Supercooling is a condition where liquid is cooled below its freezing point without becoming solid. Here's another important question from this chapter relating to the atomic structure. One of the elements in acetamide is carbon. Carbon exists in a few isotopes. Two of the carbon isotopes are carbon-12 and carbon-14. Given in the question is the standard representation of each isotope. A. What is meant by isotope? Isotopes are atoms of the same element with the same proton number but has different nucleon number. The key words are atoms, same proton number, and different nucleon number, or atoms of the same element with different number of neutrons. The key words for this second definition are atoms, same element, different number of neutrons. B. State one usage of carbon-14 isotope in daily life. The answer: to determine the age of fossils or artifacts. Make sure to answer the use, which is to determine. Answering questions in part, such as the age of fossils, will not be awarded with any marks. Give the answer in full: to determine the age of fossils or to determine the age of artifacts. C. What is represented by the number 6 in the standard representation of carbon-12? To answer this, we must understand the standard representation of an atom. The first standard representation consists of the letter C and the numbers 12 and 6. C is the symbol of element, which is the symbol of carbon. 12 is the nucleon number. And as for the number 6, it is the proton number of carbon. To answer, 6 represents the proton number. D. Write the electron arrangement of carbon-12 atom. Carbon atom is neutral. In a neutral atom, the number of electrons is the same as the number of protons. Since the proton number is 6, the number of protons and the number of electrons are 6. Therefore, the electron arrangement of carbon-12 atom is 2,4, where the first shell is filled with 2 electrons, and the second, or the outermost shell, is filled with 4 electrons. E. Why carbon is used as a standard to determine the relative atomic mass of an element? The answer: it has an accurate mass. Chapter 3: The mole concept, chemical formula, and equation. In this chapter, we will briefly go through a few important definitions, formula, and revise the experiments to determine the empirical formula of metal oxides. The actual mass of an atom is unknown. Relative atomic mass is used to compare the mass of an atom of an element to the mass of an atom of another element that is chosen as the standard. The standard in this case is carbon-12 atom. Carbon-12 atom is used as a standard because it is a solid and it has an accurate mass. Therefore, the relative atomic mass is the average mass of an atom of an element compared to 1/12 of the mass of one carbon-12 atom. The relative atomic mass of an atom can be obtained from the periodic table of elements. The relative molecular mass is the average mass of a molecule compared to 1/12 of the mass of one carbon-12 atom. The relative molecular mass can be calculated by adding up the relative atomic masses of all the atoms that form the molecule. In addition to this, we also have the relative formula mass. This concept is similar to relative molecular mass, but it is the relative mass of ionic substances. The mole concept. The mole is the unit of amount of substance. This is the diagram that shows the relationship between the number of moles, the number of particles, mass, and volume. The number of moles is equals to the number of particles divided by the Avogadro constant, or the number of moles is equals the mass of solid substance divided by the molar mass, or the number of moles is also equals to the volume of gaseous substance divided by its molar volume. To find the number of particles, multiply the number of moles by the Avogadro constant. Similarly, to find the solid mass, multiply the number of moles by the molar mass. To find gaseous volume, multiply the number of moles by molar volume. In general, compounds can be represented by two types of chemical formula: the empirical formula and the molecular formula. The empirical formula shows the simplest ratio of the number of atoms of each element in a compound. The molecular formula shows the actual number of atoms of each element found in a molecule of a compound. For example, the empirical formula of glucose is CH2O. The formula shows that the simplest ratio of the number of carbon atom to hydrogen atom to oxygen atom is 1 to 2 to 1. The molecular formula of glucose is C6H12O6. The formula shows that the ratio of the number of carbon atom to hydrogen atom to oxygen atom is 6 to 12 to 6. These numbers are the actual number of atoms of each element in a glucose molecule. Determining the empirical formula of metal oxides. There are two methods to determine the empirical formula of metal oxides. However, both methods do not apply to all metal oxides. Depending on the reactivity of the metal, the correct method is used. For more reactive metals, we heat metal with oxygen to form metal oxide. This method is suitable to determine the empirical formula of calcium oxide, magnesium oxide, aluminum oxide, and zinc oxide. For less reactive metals, we heat metal oxide with hydrogen to form metal. This method is suitable to determine the empirical formula of tin 2 oxide, lead 2 oxide, and copper 2 oxide. Here is a question relating to the empirical formula of metal oxide. Diagram shows the apparatus set up to determine the empirical formula of magnesium oxide. Note that crucible is used. This method is suitable for more reactive metals. Also given in the question is the chemical equation that represents the reaction. From the equation, magnesium reacts with oxygen to form magnesium oxide. A. What is the meaning of empirical formula? As you can see from this question, definition is very important. so make sure you know the definition of all the important concepts. The answer to this question, empirical formula, is the chemical formula that shows the simplest ratio of the number of atoms of each element in a compound. The key words are chemical formula and the simplest ratio of the number of atoms. B. State the type of particles of the products formed. The product is magnesium oxide, which is an ionic compound consisting of magnesium ion Mg2 positive and oxide ion O2 negative. Therefore, the particles present are ions. C. Why does the crucible lid have to be opened once in a while during heating? In this reaction, magnesium is heated, where magnesium reacts with oxygen to form magnesium oxide. If the lid is closed, there is no oxygen supply for the reaction to occur. Therefore, the lid has to be opened to allow the flow of oxygen for the complete combustion of magnesium. D. Table shows the results of the experiment as shown on the electronic balance. By assuming that the reaction is complete, determine the value of X. Given in the table, the mass of crucible and lid is 21.5 grams. The mass of crucible, lid, and magnesium is 24 grams, whereas the mass of crucible, lid, and magnesium oxide is X grams. To solve for X, construct this table, which is used to determine the empirical formula. Although X is unknown, do not fear. Fill the table accordingly and find solution along the way. The elements involved are magnesium and oxygen. Then we start with the mass. Mass of magnesium is 24 minus by 21.5, which is 2.5 grams. Mass of oxygen is X minus 24. No calculation can be done here as the value of X is unknown. Don't worry, keep on going. Continue with the number of moles. The number of moles of magnesium is 2.5 divided by the relative atomic mass of magnesium, which is 24. The answer is 0.104. The number of moles of oxygen is X minus by 24 divided by its relative atomic mass, which is 16. Again, no calculation can be made here. Don't worry, keep on going. Don't hesitate, don't stop. Keep on going. Finally, the simplest ratio. How can we obtain the simplest ratio without the mass and the number of moles of oxygen? If you scan through the question closely, the empirical formula of magnesium oxide is given through the chemical equation as the product of the reaction. Empirical formula of magnesium oxide is MgO. Therefore, the ratio of magnesium to oxygen is 1 to 1. If the ratio is 1 to 1, then the number of moles of oxygen is the same as the number of moles of magnesium, which is 0.104. Therefore, X minus 24 over 16 is equals to 0.104. From here, solve for X. To find X, you can use your calculator. Key in the equation into your calculator and then solve for X. we will get X is equals to 25.67 gram. E. How can you ensure that the reaction has completed? To ensure the reaction has completed, we repeat the heating, cooling, and weighing processes until a constant mass is obtained. F. Can the empirical formula of lead-2 oxide be determined using this method? Give a reason for your answer. In this method, we heat metal with sufficient oxygen supply to form metal oxide. This method is suitable for more reactive metals such as calcium, magnesium, aluminium, and zinc. Lead is less reactive. Lead does not react with oxygen to form lead-2 oxide. So the answer is no. Why? Lead is less reactive than magnesium. For less reactive metals, the empirical formula can be determined by heating the metal oxide with hydrogen gas. The reaction will produce metal and water. Here's another question relating to chemical equation. Potassium reacts with water to form an alkali and a colorless gas. The chemical equation of the reaction is as follows: XK solid plus YH2O liquid to form ZKOH aqueous plus H2 gas. A. Balance the chemical equation for the reaction by determining the values of X, Y, and Z. Based on the equation, the number of hydrogen atoms on the left-hand side of the equation is not the same as the ones on the right-hand side. We have 2 hydrogen atoms on the left and 3 hydrogen atoms on the right. To balance hydrogen atoms, Y is equals to 2 and Z is equals to 2. With that, the number of hydrogen atoms and oxygen atoms are balanced. To balance potassium atoms, X is equals to 2. Thus, the answer, X equals to 2, Y equals to 2, and Z equals to 2. B. Interpret the above chemical equation quantitatively. From the quantitative aspect, we study the stoichiometry of chemical equations. To do that, simply state the mole ratio of how the reactants form the products. In this question, 2 mole of potassium reacts with 2 mole of water to produce 2 mole of potassium hydroxide and 1 mole of hydrogen gas. C. Calculate the mass of potassium needed to release 50 cm³ of hydrogen gas at room conditions. To begin, we find the number of moles based on the quantity given, which is 50 cm³ of hydrogen gas. But remember to change the volume in cm³ to dm³. 50 cm³ is equivalent to 50 divided by 1000, which is 0.05 dm³. Number of moles of hydrogen is equals to volume divided by molar volume, which is 0.05 divided by 24 equals to 0.002 mole. Based on the chemical equation, the ratio of hydrogen to potassium is 1 to 2. 1 mole of hydrogen is produced by 2 mole of potassium. Therefore, 0.002 mole of hydrogen is produced by 0.004 mole of potassium. Finally, to calculate the mass of potassium is the number of moles multiplied by the molar mass of potassium, which is 0.004 multiplied by 39. The answer is 0.156 gram. Chapter 4, the periodic table of elements. In Chapter 4, we focus on the arrangement of elements in Group 18, Group 1, Group 17, Period 3, and the transition elements. Arrangement of elements in the periodic table. Elements are arranged in ascending order of proton number. Periods are horizontal rows. The number of shells filled with electrons will determine the period of an element. Elements of the same period have different chemical or physical properties. Groups are vertical columns. The number of valence electrons determine the group of an element. Elements of the same group have the same chemical properties. However, reactivity and physical properties may vary gradually. Group 18 elements. Group 18 elements are also known as noble gases. Group 18 elements are chemically unreactive or inert. Why? Atoms have valence or outermost shells that are fully filled with electrons. Atoms have achieved stable duplet or octet electron arrangement. Atoms do not donate, accept, nor share electrons with another atoms. Therefore, atoms exist as monoatoms. Group 1 elements are alkaline metals. Atoms of Group 1 elements have 1 valence electrons. To achieve stable duplet or octet electron arrangement, atom donates 1 electron to form a positive ion with positive 1 charge. Reactivity of elements increases when going down Group 1. When going down Group 1, atomic size increases. Valence electrons are further from the nucleus. Nuclear attraction force towards the valence electrons becomes weaker. Atom donates electron more easily to form a positive ion. Group 17 elements. Group 17 elements are halogens. They are non-metals. Atoms of Group 17 elements have 7 valence electrons. To achieve stable octet electron arrangement, halogen atom may share 1 electron with another atom or another halogen atom. Therefore, Group 17 elements exist as diatomic molecules. To achieve stable octet electron arrangement, halogen atom may also accept 1 electron and forms a negative ion with negative 1 charge. Reactivity of elements decreases when going down Group 17. When going down group 17, atomic size increases. Valence electrons are further from the nucleus. Nuclear attraction force towards valence electrons becomes weaker. Atom accepts electron more difficultly to form a negative ion. Period 3 elements. Electropositivity decreases and electronegativity increases when going across period 3. When going across period 3, atomic size decreases. As the number of protons increases, the atomic nuclear charge increases. Nuclear attraction force towards valence electrons becomes stronger. Atom donates electrons with more difficulty to form positive ion. Atom is less likely to donate electrons. Electropositivity decreases. Atom accepts electrons more easily to form negative ions. Atom is more likely to accept electrons. Therefore, electronegativity increases. Going across period 3, the physical state of period 3 elements change from solid to gas. The same goes for their metallic properties. Metallic properties decrease. Going across period 3, elements change from metal to semi-metal to non-metal elements. Sodium, magnesium, and aluminium are metals. Silicon is semi-metal or metalloid, whereas phosphorus, sulfur, chlorine, and argon are non-metals. Going across period 3, the properties of oxide change from basic oxide to amphoteric oxide, and then to acidic oxide. Group 1 and 2 elements form metal oxides that are basic. When dissolved in water, both basic oxides will produce alkaline solutions. Basic oxides also react with acid to form salt and water. Aluminium forms metal oxide that is amphoteric in property. Aluminium oxide reacts with both acid and alkali to form salt and water. Elements from groups 14, 15, 16, and 17 form non-metal oxides that are acidic in property. When dissolved in water, oxides of elements from these groups will produce acidic solutions. Acidic oxides will also react with alkali to form salt and water. Transition elements. Transition elements are placed in group 3 to group 12 in the periodic table. Transition elements are metals with high melting and boiling points, hard, shiny surfaces, malleable, and ductile. Transition elements have special characteristics unknown to other metals. These special characteristics are: they function as a catalyst to increase the rate of reaction. For example, iron is used in Haber process to produce ammonia. They form color ions or compounds. For example, iron can form iron 2 ion by donating 2 electrons, and also form iron 3 ion by donating 3 electrons. Iron 2 ion is green in color, whereas iron 3 ion is brown in color. They also form complex ions. For example, iron forms hexacyanoferrate 2 ion and hexacyanoferrate 3 ion. These ions are complex ions. Lastly, they form more than one oxidation number. For example, the oxidation number of iron in iron 2 sulfate is positive 2. The oxidation number of iron in iron 3 chloride is positive 3. Here are some tips on how you can distinguish the physical and chemical properties of the elements. The secret is in your hands. Place your hand vertically. This represents group. The palm of your hand forms a triangle that looks like a mountain. For elements in a group, atomic size increases when going down the group. If you place your hand horizontally, this represents period. Again, the palm of your hand forms a triangle, but this time it looks like a triangular flag. For elements in a period, atomic size decreases across the period. Now, make a peace symbol with your right hand and open your palm on the left hand. Then place them side by side. Your fingers will represent the groups in the periodic table. Starting with the thumb of your left hand is group 1. Your index finger, group 2. The middle and the ring finger are the transition elements. And the pinky finger is group 13. Elements from the groups on your left hand will donate electrons. And as atomic size increases when going down the groups, atoms donate electrons more easily. Therefore, reactivity increases. On the right hand, starting with the pinky finger, is group 14. The ring finger, group 15. The middle finger, group 16. The index finger, group 17, and ends with the thumb, group 18. Elements from group 14 to 17 will accept or share electrons. And as atomic size increases when going down the groups, atoms accept electrons with more difficulty. Therefore, reactivity decreases. As for group 18, elements are inert. Atoms do not donate, share, or accept electrons with another atom. Here is a question relating to the periodic table of elements. Diagram shows several elements in the periodic table. The symbol P, Q, R, S, T, U, V, and W are not the actual symbol of the elements. A. Write the electron arrangement of atom P. Atom P is placed in period 2. Atom P has 2 shells filled with electrons. Atom P is also placed in group 2. Atom P has 2 valence electrons. Therefore, the electron arrangement of atom P is 2, 2. B. Why W is chemically unreactive? W is placed in group 18. W is a noble gas which is inert. Atom has valence or outermost shells that are fully filled with electrons. Atom has achieved stable octet electron arrangement. The key words are atom and stable octet electron arrangement. C. Why are Q and R placed in group 1? Atoms Q and R are placed in the same group. The number of valence electrons determine the group of an element in the periodic table. As Q and R are placed in group 1, atoms have 1 valence electrons. D. Elements R is more electropositive than Q. Explain why. Electropositivity is the ability of an atom to donate electron to form a positive ion. Electropositivity is reactivity of a metal. To explain why R is more electropositive than Q, atomic radius of R is bigger. Attraction force of nucleus towards valence electrons of R is weaker. Atom R donates electron more easily. To compare, use comparative adjectives such as bigger, weaker, and more easily. Which element forms a diatomic molecule? Halogens, which are group 17 elements, exist as diatomic molecules. The answer is V. Halogen atom has 7 valence electrons. To achieve stable octet electron arrangement, halogen atom contributes 1 electron to be shared. One halogen atom shares electron with another halogen atom. A covalent compound, which is a diatomic molecule, is formed. Which element forms an amphoteric oxide? This refers to aluminium, which is T. Aluminium forms aluminium oxide that is amphoteric in property. Aluminium oxide, which is amphoteric oxide, has both basic and acidic properties. Aluminium oxide reacts with both acid and alkali to form salt and water. Which element forms a colored compound? This special characteristic, which is unknown to other metals, belongs to the transition elements. Therefore, the answer is S. F. V dissolves readily in water. Part 1. Predict the observation if a litmus paper is deep in the solution. Group 1 elements are alkaline metals. Therefore, group 17 elements are acidic. In addition to that, group 17 elements, which include chlorine, often found in Clorox, have bleaching properties. Therefore, V, which is also a group 17 element, have both acidic and bleaching properties. When a litmus paper is deep in the solution dissolved with V, the blue litmus paper turns red, then colorless. Part 2. Write an equation that occurs between V and water. Halogen exists as diatomic molecules. Therefore, V2 reacts with water H2O to form 2 types of acids, HV and HOV. Chapter 5. Chemical bond. Chemical bonds are formed so that atoms can achieve stable duplet or octet electron arrangements. Therefore, noble gases or group 18 elements exist as monoatomic gases that are not reactive chemically. This is because atoms have achieved stable duplet or octet electron arrangement. Therefore, atoms of group 18 elements do not donate, accept, or share electrons with another atom. For atoms of other elements, Stability can be achieved by transferring or sharing of electrons. Chemical bonds only involve the valence electrons. In this chapter, we will look at 5 types of bond: the ionic bond, covalent bond, hydrogen bond, dative bond, and the metallic bond. Ionic bond. Ionic bond is formed by the transfer of electrons between a metal atom and a non-metal atom to achieve stable duplet or octet electron arrangement. For example, ionic bond is formed when magnesium reacts with oxygen. Electron arrangement of magnesium atom is 2-8-2. Electron arrangement of oxygen atom is 2-8-6. To achieve stable octet electron arrangement, magnesium atom donates 2 electrons to form magnesium ion, Mg2 positive ion. Oxygen atom accepts 2 electrons to form oxide ion, O2 negative ion. Magnesium ion and oxide ion are attracted by strong electrostatic forces. Ionic bond is formed. Ionic compound, which is magnesium oxide, MgO, is formed. Covalent bond. Covalent bond is formed by the sharing of electrons between non-metal atoms to achieve stable duplet or octet electron arrangement. For example, covalent bond is formed when water molecule is formed from the reaction between hydrogen and oxygen. Electron arrangement of hydrogen atom is 1. Electron arrangement of oxygen atom is 2-6. To achieve stable duplet or octet electron arrangement, hydrogen atom contributes 1 electron to be shared. Oxygen atom contributes 2 electrons to be shared. 1 oxygen atom shares electrons with 2 hydrogen atoms. Covalent bond is formed. Covalent compound, which is water, H2O, is formed. Comparing the difference in physical properties between ionic compound and covalent compound. Ionic compound can light up the bulb in an electrolytic cell. It conducts electricity in molten and aqueous solution. It has free moving ion. Covalent compound does not light up the bulb. It does not conduct electricity in all physical states. Molecules are neutral. There are no free moving ions. Ionic compound is soluble in water, but insoluble in organic solvents. Ions move freely in water. Covalent compound is insoluble in water, but soluble in organic solvent. Molecules form weak van der Waals forces with molecules of organic solvents. When heated, ionic compound does not melt or boil easily. Melting and boiling points of ionic compound is high. Oppositely charged ions are attracted to one another by strong electrostatic forces. When heated, covalent compound melts and boils easily. Melting and boiling point of covalent compound is low. Molecules are attracted to one another by weak van der Waals forces. Hydrogen bond is the attraction force between hydrogen atom bonded to a high electronegative atom such as fluorine, oxygen or nitrogen, with fluorine, oxygen or nitrogen atom in another molecule. To remember, use mnemonic hand font, H and font. H represents hydrogen, F, O and N represent fluorine, oxygen and nitrogen respectively. The presence of hydrogen bond affects the physical properties of covalent compounds such as the melting and boiling points and the solubility in water. For example, ammonia is a covalent compound that is soluble in water. In ammonia molecule, hydrogen atom that is bonded to a high electronegative nitrogen atom is attracted to the oxygen atom in the water molecule. Hydrogen bond is formed between ammonia molecule and water molecule. Therefore, ammonia is soluble in water. Dative bond or coordinate bond is a covalent bond where the electron that is shared comes from one atom only to achieve a stable duplet or octet electron arrangement. Dative bond is formed in hydroxonium ion H3O positive, where oxygen atom of the water molecule contributes one lone pair of electrons to be shared with the hydrogen ion H positive. Metallic bond is an electrostatic attraction force between the positively charged metal ion and the sea of electrons. Metal atoms donate and delocalize valence electrons easily. Metal atoms form positively charged metal ions. Delocalized valence electrons move freely to form a sea of electrons. Positively charged metal ions and sea of electrons are attracted by strong electrostatic force. Metallic bond is formed. We will discuss the formation of bonds in detail through the questions. Here is one of the questions. Hydrogen and nitrogen react to form compound X. A. Explain the formation of compound X. To explain, begin with the electron arrangement of the atoms involved. Electron arrangement of hydrogen atom is 1. Electron arrangement of nitrogen atom is 2, 5. Then, explain how these atoms achieve the stability of electron arrangement. To achieve stable duplet or octet electron arrangement, hydrogen atom contributes 1 electron to be shared. Nitrogen atom contributes 3 electrons to be shared. Then, explain how the compound is formed through sharing of electrons. 1 nitrogen atom shares electrons with 3 hydrogen atoms. Finally, ends with the type of bond and the type of compound formed. Covalent bond is formed. Covalent compound NH3 is formed. B. Carbon reacts with hydrogen to form methane, CH4. Compare the solubility in water between methane and compound X. To compare, the points can be clarified through a table. Both methane and compound X, which is ammonia, are covalent compounds. Covalent compounds are insoluble in water. However, their insolubility may be altered when the compound forms hydrogen bond with water. For this to occur, the covalent compound must have Hen bond, H and bond, which is hydrogen atom bonded to a high electronegative fluorine, oxygen, or nitrogen atom. Methane molecule has hydrogen atom bonded to carbon atom. Therefore, methane is insoluble in water. Molecule of compound X has hydrogen atom bonded to nitrogen atom. Therefore, compound X is soluble in water. To explain, in methane, hydrogen atom bonded to less electronegative carbon atom is not attracted to the oxygen atom in water molecule. In compound X, hydrogen atom bonded to more electronegative nitrogen atom is attracted to oxygen atom in water molecule. When explaining, show the differences. The differences are less electronegative carbon atom with more electronegative nitrogen atom, and is not attracted with is attracted. This difference results in methane molecule does not form hydrogen bond with water molecule. Molecule of compound X forms hydrogen bond with water molecule. Again, make sure the points written indicate a difference. Does not form and forms hydrogen bond with water molecule. Next question. Proton number of sodium is 11 and proton number of chlorine is 17. A. Sodium and chlorine react to form compound Y. Explain the formation of compound Y. To explain, begin with the electron arrangement of the atoms involved. Electron arrangement of sodium atom is 2, 8, 1. Electron arrangement of chlorine atom is 2, 8, 7. Then, explain how these atoms achieve the stability of electron arrangement. To achieve stable octet electron arrangement, sodium atom donates one electron to form sodium ion, Na positive ion. Chlorine atom accepts one electron to form chloride ion, Cl negative ion. Then, explain how the compound is formed through these ions. Sodium ion and chloride ion are attracted by strong electrostatic forces. Finally, ends with the type of bond and the type of compound formed. Ionic bond is formed. Ionic compound sodium chloride, NaCl, is formed. B. Draw an apparatus set up to determine the electrical conductivity of compound Y. To determine the electrical conductivity of compound Y, we must construct an electrolytic cell consisting of batteries, connecting wires, electrodes, and electrolyte. The apparatus setup drawn must be functional. The batteries should be connected to a light bulb or a voltmeter to show the electrical conductivity of the compound, and then connected to two separate carbon electrodes. The carbon electrodes are deep in compound Y, which is sodium chloride. Solid compound Y must be heated to produce free moving ions. If the light bulb lights up, compound Y conducts electricity in molten state. There are free moving ions. If the light bulb does not light up, compound Y does not conduct electricity. There are no free moving ions. C. Diagram shows a beaker containing a mixture of naphthalene and compound Y. Describe briefly how naphthalene and compound Y can be separated. To solve the problem, identify the difference between naphthalene and compound Y. Naphthalene is a covalent compound. Physical properties of a covalent compound are low melting and boiling points, insoluble in water, soluble in organic solvent, does not conduct electricity in all physical states. Compound Y, which is sodium chloride, is an ionic compound. Physical properties of an ionic compound are high melting and boiling points, soluble in water, insoluble in organic solvent, conducts electricity in molten and aqueous state. Based on these physical properties, identify how we can separate them. As naphthalene and compound Y have different solubilities, we can separate them by dissolving the mixture with water. By doing so, compound Y will dissolve in water, while naphthalene will not. So we add distilled water into the mixture and stir. We add water and stir. To separate them, we filter, and finally, we rinse. Here is a question relating to the dative bond. When hydrogen chloride is dissolved in water, hydrochloric acid is produced. Diagram shows the electron arrangement of hydrogen chloride and water. A. What is the purpose of the formation of chemical bond? The answer: to achieve stable duplet or octet electron arrangement. In this question, hydrogen atom forms covalent bond to achieve stable duplet electron arrangement. Oxygen atom and chlorine atom form covalent bond to achieve stable octet electron arrangement. Therefore, the purpose of the formation of chemical bond is to achieve stable duplet electron arrangement for hydrogen atom and to achieve stable octet electron arrangement for oxygen atom and chlorine atom. B. Write an ionic equation for the reaction. When hydrogen chloride dissolves in water, hydrochloric acid is formed. Hydrochloric acid consists of ions, namely the hydroxonium ion, H3O positive ion, and the chloride ion, Cl negative ion. The ionic equation is H2O plus HCl will form H3O positive plus Cl negative, where 1 mole of H2O reacts with 1 mole of HCl to form 1 mole of H3O positive and 1 mole of Cl negative. Hydroxonium ion, which is H3O positive ion, is formed when hydrogen ion H positive from the hydrogen chloride molecule shares a lone pair of electrons from the oxygen atom of the water molecule. C. Draw the electron arrangement of the product of the reaction and label the bond formed. In hydrogen chloride, hydrogen atom has 1 valence electron. Chlorine atom has 7 valence electrons. To achieve stability in electron arrangement, hydrogen atom donates 1 electron to form hydrogen ion, H positive ion. Chlorine atom accepts the electron to form chloride ion, Cl negative ion. Now hydrogen ion, H positive ion, does not have any electrons in its outermost shell. Oxygen atom of the water molecule has 2 lone pairs of electrons. Oxygen atom will contribute 1 lone pair of electrons to be shared with the hydrogen ions. 1 oxygen atom of the water molecule shares electron with 1 hydrogen ion, H positive. Dative bond is formed between oxygen atom of the water molecule and the hydrogen ion, forming the hydroxonium ion H3O positive in hydrochloric acid. D. Explain how hydroxonium ion H3O positive is formed. Hydrogen ion does not have any electrons. Oxygen atom in water molecule shares 1 lone pair of electrons that are not involved in covalent bond with hydrogen ion. Last question. Diagram shows the giant 3-dimensional lattice structure for sodium atom. A. Label the structure of A and B in the space provided. Sodium is a metal. Therefore, sodium atoms are arranged closely packed and orderly in the solid state. Although in the solid state, valence electrons of sodium atoms can be donated easily and delocalized. When valence electrons are delocalized, sodium ions that are positively charged are formed. All delocalized valence electrons can move freely between the metal structure and form a sea of electrons. Based on the diagram given, A is the sea of delocalized electrons. B is the positively charged sodium ion. B. What is the type of bond present in sodium atom? In metal, electrostatic attraction force between the sea of electrons and the positively charged sodium ions form the metallic bond. C. Explain how the bond in B is formed. To form the metallic bond, sodium atom donates valence electrons and forms sodium ion and A positive ion. Valence electrons are delocalized into a sea of electrons. Sodium ion and sea of electrons are attracted by strong electrostatic forces. Therefore, metallic bond is formed. D. Explain how sodium can conduct electricity. Covalent compound does not conduct electricity in all physical states. Molecules are neutral. There are no free-moving ions. Ionic compound conducts electricity in molten and aqueous solution. Ionic compound consists of ions. In molten or aqueous solution, ions move freely. Sodium consists of metal atoms only. So how does sodium conduct electricity without having free-moving ions? Since sodium atoms are closely packed and orderly arranged, valence electrons of sodium atom are donated easily. Valence electrons are delocalized into a sea of electrons. Delocalized electrons move freely. Delocalized electrons carry charges from the negative terminal to the positive terminal. With that, we have come to the end of the first slot. If you have been paying attention, in Chapter 2, we have learned that there are three physical states of matter: solid, liquid, and gas. When solid changes to liquid or liquid changes to gas, there is no change in temperature. Heat energy absorbed by the particles is used to overcome the attraction force between the particles. When gas changes to liquid or liquid changes to solid, there is no change in temperature. Heat energy lost to the surrounding is balanced by heat energy released when particles attract each other. In Chapter 3, we have learned how to use the relationship between the number of moles with solid mass and gaseous volume to solve problems involving calculations. Number of moles is equals to mass divided by molar mass. Number of moles is also equals to volume divided by molar volume. Based on the chemical equation, use the mole ratio to determine the number of moles of substance we are looking for. Then we solve the problem. To find mass, multiply the number of moles by the molar mass. To find volume, multiply the number of moles by molar volume. We also learned that to determine the empirical formula of metal oxides, for more reactive metal, we heat metal with oxygen. For less reactive metals, we heat metal oxide with hydrogen. In Chapter 4, use your fingers to distinguish the changes in the physical and chemical properties of elements in the periodic table. Place hand vertically to represent group. Atomic size increases when going down the group. Place hand horizontally to represent period. Atomic size decreases when going across the period. Peace symbol on the left hand shows the groups of elements that donate electrons. Reactivity increases going down the group. Open palm on the right hand shows the groups of elements that accept or share electrons. Reactivity decreases when going down the group. In Chapter 5, we have learned that chemical bonds are formed so that atoms can achieve stable duplet or octet electron arrangements. Ionic bond is formed by the transfer of electrons. Covalent bond is formed by sharing of electrons. Hydrogen bond is formed when hydrogen atom bonded to highly electronegative fluorine, oxygen, or nitrogen atom is attracted to these atoms in another molecule. Dative bond is formed when the lone pair of electrons shared comes from one atom only. Metal atom donates electrons and becomes positively charged. Valence electrons are delocalized into a sea of electrons. Strong electrostatic force between positively charged metal ions and sea of electrons form the metallic bond.